I'm Colin Ribton, I work at TWI, which is a materials joining consultancy really, based in Cambridge. I work in the Electron beam group, so we look at electron beam gun design for welding, material servicing, electron beam printing. My primary role is design of electron beam equipment.
So this is for coating materials or for joining different types of materials
Exactly,
together?
yeah. And in printing it's powder bed printing mainly, but also we do additive manufacture with wire for 3D building of objects.
And how does the creation of electron beam enable that to happen?
Well, electron beam's a very intense energy source, so you can melt just where the beam goes. So compared with other heating sources like arcs and similar things, you get very low distortion, you get localized melting and then rapid freezing. And
for the electron beam gun design, what are the key parameters that you're actually looking for?
Generally you're looking for intensity, and often intensity at long distance. So it's the electron gun as the primary source of electrons needs to be a very high integrity source, a good electron optical source. And then you have the electron optical elements, that includes the lenses and deflection coils that move the beam down to the workpiece where it's finally focused into an intense spot. But a lot of processes rely on the beam being projected quite a long way. So in welding, for example, welding of aero engines can sometimes require you to throw the beam 1.5 meters away from the gun.
That's quite a way.
And you want that beam to be maybe 0.5 millimeter in diameter when it gets to the workpiece.
So how do you use Opera to help you with that process?
Well, Opera primarily provides a real insight into the gun and how the gun works. So we can design guns looking at the cathodes, the geometry around the cathode and the material that we use. But also ensure that we have a gun that works across the beam power range.
Right, and does Opera allow you to optimize the process for doing the welding?
Absolutely, and what I've been talking about here today has been optimizing electron guns automatically, because we have many different requirements for electron guns, we have many different designs of gun. We need to be able to design them rapidly and also know that we've designed something that's suitable for the requirements.
It sounds very complex. How long have you been using Opera?
Quite a long time. I think it's 32 years actually.
Really? That's a long time.
My first job was using the early versions of Opera, and I've seen it change over the years.
Okay, for the better hopefully.
Oh, very much for the better and for wider use. Initially I only used Opera for designing electron lenses and electromagnetics, and then it became capable of solving electron guns as well with the space charge solver. Right. And I've been using it for electron gun analysis for the last 20 years or so. So
is there a particular aspect of Opera that you really favour and that you rate highly?
The open nature of the software is a real benefit for us, because the software generates files where you can go back and interrogate that information with other software or graph that information out. One of the things that we really like to do is look at trends in the design. So you can make a number of designs and then look how the beam changes over the beam current range or as you change voltage on the gun, and understand really what's going on in the design process and how you can improve things. And it's now given us a very accurate tool for the design of guns that we carry out. We're working for many clients in the design of electron guns as well, so there are many companies out there benefiting from it.